Hi, welcome to the video on similar area. In the last video we looked at similar length. Now, what's the difference between a length and an area? Well, a length is a line, okay, so we're just dealing with lines for similar length, and when we deal with similar area we're actually dealing with a space. So we think about areas being in two dimensions, having a length and a breadth. Alright, so basic shape to the area is rectangle. So let's start off with this, okay? So it's a wee problem this time. So two rectangular tabletops are similar in shape. Remember, mathematical similarity means that they have congruent angles but different lengths, alright? The larger tabletop has an area of 1.2 square metres. What is the area of the smaller one? So let's fill in that information. So the larger tabletop has an area of 1.2 square metres, and we are looking for the area of the smaller one, and we're going to call that A for the now, okay? So, first thing we need to do, just like with similar lengths, we need to find the scale factor first of all, okay? So, remember, for scale factor, we just use SF. Now, what we need is we need two corresponding sides. Here we go, 0.9 and 1.35, and because it's a reduction in size, it's going to be 0.9, it's going to go on the top of that fraction. So 0.9 over 1.35. Now, this is where similar area becomes different to similar lengths. Because we're dealing with two dimensions here, we're not just dealing with one line, right? We can see that this rectangle is getting bigger in two directions. So the breadth's getting bigger, and also the length is getting bigger as well. So what we do is, with the scale factor, we square it. Okay, so we square the scale factor. Now, how are we going to do this calculation? I'm going to show you. I'm going to show you in a slightly different way to I normally would. So 0.9 divided by 1.35, this is how we do it, okay? There's the calculator, right? So 0.9 divided by 1.35, and then all I'm going to do is I'm going to press this square button right here. So I don't round it first, and I get 0.444, okay? So I'm just going to write that down just now. So I've rounded that to two decimal places. I don't want you doing 0.9 divided by, saved by the bell, we'll wait for that. I don't want you doing 0.9 divided by 1.35, getting 0.666 and then rounding that and then squaring it, okay? I want you to do it the way I showed you on the calculator there, so rewind that if you need to, okay? I've rounded this answer just to write it down. I don't want to be writing 4s until I'm 64, okay? So 0.44, I've rounded to two decimal places for the sake of the calculation, right? So remember, we've squared the scale factor because it's area, alright? Now, what do we do next? Just as before, all we need to do is we multiply the 1.2 that we have by the scale factor to get our A value. So A is equal to 1.2 times 0.44. Now, that's fine to communicate with me or whoever's looking at your work that that's what you've done. Okay, but again, I'm going to show you how to do this in the calculator. Okay, so my calculator is sitting like this. 0.444 keeps going, and all I'm going to do is press times 1.2 and then equals, and I get 0.533 recurring. Alright, so that's what I'm going to write down. And remember, that's in metres squared, and I have rounded it. Okay, again I've rounded to two decimal places, so that's fine, right? But we should remember that the answer is 0.53 recurring. If you wanted to, you could put a little dot above the 3 to show that that's recurring there, alright? So, basic point today is, similar area we have to square the scale factor because we're making it larger or smaller in two directions, okay? Not just in one direction, in two directions, so it's like two-dimensional shapes. This time, as opposed to lines, which is just enlarging or reducing in one direction. Okay? So again, you can rewind that, guys, if you want to. Pay close attention to what we did with the calculator, it's really important. Alright, and that's it. Thank you very much.